Have you ever wondered how we tell computers what to do? It's not actually magic. It's a language. And just like any other language, it's built on a few really simple but super powerful ideas. So in this explainer, we're going to break down the 5 fundamental concepts that are the absolute foundation of all programming.
So, yeah, how do you speak computer? You can't just talk to it. You need a structured, logical way to give it instructions. But believe it or not, the basic rules are probably a lot more straightforward than you think. Today, we're going to walk through the 5 core concepts that'll let you write those instructions. If you can master these, you are well on your way. So, let's get started with the very first one. First up, variables and data types. Think about it. Before a computer can calculate anything or make a decision or do anything useful at all, it needs a place to store the information it's going to work with. We call these little storage spots identifiers. As you can see here, it's really just a name for a piece of data that's stored in the computer's memory. The absolute easiest way to think about it is like a labeled box, right? You give the box a name, that's the identifier, you put your data inside, and now the computer always knows exactly where to find it. Now these identifiers, they come in 2 main flavors. So on one side, you've got variables, where the data inside that box can change. A perfect example is your score in a game. It's always going up and down. On the other side, you've got constants. These are set just one time and they never, ever change. Think of something like the maximum number of lives you can have in that game.
All right, time for a quick little pop quiz. What's the key difference between a variable and a constant?
Exactly. A variable is flexible. A constant is totally fixed. And that's the key, right? The crucial part is knowing when you need your data to be able to change and when it absolutely needs to be rock solid.
Now, those boxes can't just hold anything you want. You have to tell the computer what kind of information is going inside. So is it a whole number, like say 7? We call that an integer. Or is it a number with a decimal, like 3.14? Well, that's a float. Is it just plain text? We call that a string. Or is it a simple true or false value? That, my friends, is a Boolean.
And get this, here's a perfect real-world example of why this is so important. If you try to store a zip code like 07030 as a number, the computer will just drop that leading 0 and see it as 7030, which is a completely different place. But if you store it as text or a string, it keeps it exactly as you intended. See? Pretty crucial stuff.
Okay, so we can store single pieces of information. That's great. But what if you have a whole collection of related data, like, a list of high scores? Well, that's where our second building block, the array, comes into play. So meet the array. Just think of it like an egg carton. It's one container, right? But it holds a dozen individual items of the exact same type, in this case eggs. An array is just that, a single variable that can hold multiple values, all while keeping them super neat and organized.
Now, here's a concept that trips up a lot of beginners, so listen up. In programming, we almost always start counting from 0. So the first slot in our little egg carton isn't position 1, it's position 0. The second item is at position 1, the third is at position 2, and it just keeps going like that. This is a really fundamental idea, and it's called zero indexing.
So keeping that in mind, if you have an array called ages, how would you get to that very first element?
You got it. You use the name of the array, and you follow it with the index number inside square brackets. And since we always start at 0, the very first item is always at index 0.
All right, so far we've stored data and we've organized it. Now let's talk about the actual instructions. How can we write code that's efficient, clean, and doesn't just repeat itself over and over and over again?
This is where functions come in. And trust me, they are a game changer. A function is basically like a recipe. You write down the steps for a very specific task just once, let's say how to calculate a player's final score. Then, anytime you need to do that, you just call the function by its name instead of writing out all those steps again.
So why does this matter so much? Well, it's the difference between clean, manageable code and a complete, tangled mess. You write less code, which means there are fewer places for bugs to hide. And if you ever need to update that task, you only have to change it in one single place, inside the function itself. It's really the secret to writing smart, not just writing hard.
Okay, we've covered storing data and writing reusable instructions. Our fourth building block, the object, is where we get to bring these 2 amazing ideas together into one seriously powerful package. I want you to think of an object as a blueprint. So a blueprint for a car, for example, has all the data about that car, its color, its make, its model, and it also has all the actions it can perform,
like a function to start engine or one to accelerate. An object is just a really powerful way to bundle related data and functions together.
So in the programming world, we have special names for these two parts. The data, like an employee's salary, we call those attributes. And the actions, the functions that are tied to that data, like giving that employee a raise, we call those methods.
Okay, one last check-in here. Looking at these two, which one is the method? Is it the piece of data, or is it the action?
That's right. Grant raise is the method, because it's the action. It's the doing part of the object. The salary would be the attribute. That's the data that the method actually acts on.
And there you have it. We've gone from storing single little pieces of data all the way to building these complex blueprints. These 5 concepts, they are your core toolkit for learning how to speak computer.
So, let's do a super quick recap. We've got variables, our labeled boxes for data. We have data types, which tell us what kind of stuff goes in the box. We have arrays, our egg cartons for organizing a bunch of items. We have functions, which are our reusable recipes. And finally, objects, the master blueprints that bring everything together.
These 5 building blocks, they're the start of absolutely everything, from the simplest little script to the most complex application you can imagine. The only question left is, with these fundamental tools now in your hand, what are you going to build first?